Alright, hello everyone. Today we're going to be talking about how to solve for finding the kinetic and potential energies. So you already know what kinetic and gravitational potential energy are, but here is how we can apply the formulas to solve the problems. So if we have a look at kinetic energy to start off with, kinetic energy, we have EK is equal to half mv squared. Now, m refers to the mass of the object. So m is looking at mass measured in kilograms. Okay, and v is velocity. So that's for kinetic energy. And then if we have a look at gravitational potential, a change in gravitational potential energy is equal to the mass times gravity, 9.81, times the change in height. H is equal to height. All right. So there's a few different situations where you have to apply these two formulas here. For example, we might have a question that says we have a 3 kg object that is dropped from rest at a height of 10 meters. All right. And then we also know, and then we're asked to find the velocity just before it hits the ground, assuming no air resistance. So this is one of those questions where we have to use both formulas. We have to combine the two because due to the conservation of energy, all potential energy converts into kinetic energy. So we can go the change in potential energy is equal to the change in kinetic energy. So that means that our two formulas will be equal to each other. So we'll have mg delta h, this will be lowercase h there, is equal to half mv squared. All right, and then we just have to sub in what we know. So we know m, we know g, and we know h. So if we put that into our formula, then we will get 3 times 9.81 times 10 is equal to half times 3 times v squared. Okay, now we can simplify this and rearrange to make v the subject, and then eventually we'll get something that looks like this. V squared is equal to 2g delta h, or we know those values as 2 times 9.81 times 10, and that'll give us 196 is equal to v squared. And then we just have to find the square root of that, and we'll get v is equal to 14 meters per second. And that's our value for the velocity for that situation. So that's how we can combine, and you'll often see that questions will need to use both of these formulas to calculate the kinetic and gravitational potential, so we can find things like velocity or height. Okay, so to summarize, kinetic energy is calculated using EK equals half mv squared, and changes in gravitational potential energy using delta EP equals mg delta h. In the absence of friction, total mechanical energy is conserved. So EK plus change in EP equals 0. However, if we're looking at friction, the difference between the initial potential energy and the final kinetic energy equals the energy lost to heat. All right, follow for daily QCAA content.